Hello, Tom from EveryStepPhysics.com, EveryStepCalculus.com. This obviously is a physics problem, so we're going to do it. I'm going to show you how it's done. You can go on to and put this into the Google and come up with all the problems that similar to this with regards to positions of particles, and my programs will answer step by step all those problems, along with a million other problems in physics. I don't know how anybody passes a physics test without these programs. I certainly couldn't do it. Anyways, you put physics into the home screen of the calculator here. Now notice you have to, let's do a little bit of it here. To put the letters in here, you'd have to go second alpha. If you put second alpha, changes the calculator to the secondary position of the, and we'll put in just the letters above these numbers. For instance, we go second alpha, and then we put in physics, which would be store here. That's P. Number 8 is H. Kind of a slow thing. You have to look at the calculator and see the letters above that. PHY, here's Y. And then the 3 is S. And 9 is I. And C is the left parentheses, and then we have to press alpha and put the right and left and right parentheses in, and then we can go to the menu. Okay, I'll show you that in my instruction, but another quicker way to do that would be to go second, the minus sign, which is variable link over here above the minus sign, shows you all the programs. I don't have all the programs in here, I've just got a few of them because the simulator can't handle that, but your titanium can. And then to get down to the P section of this alphabet here, I would press 1, which is Q, and it goes to the Q section. Here's physics right above that. I go up and highlight that, and it puts it in here without the right parentheses, so we would enter that and then press enter. Now I didn't clear the home screen when I put this in, so I'm going to go back here to physics, and then I'm going to press enter, and then we're into now. I didn't put the S in here. Let's put alpha. And so now we're into the main menu of physics. All these things are right down here. Many choices, you know, of what they ask for you in these problems here. Generally, whatever they ask for, that's what would be in the menu. If they ask for acceleration, you go to acceleration. If they ask for volume, you go to the volume. If they ask for tension, you go to tension, etc. Okay, and then you look for the choices of variables. Now this is velocity, so we want to get to velocity, which is at the end of the alphabet here. So to get there quickly, I'm going to go up with the cursor here, which goes to the bottom of the alphabet. Young's is my last program in there, and we're going to scroll up to velocity, and then we have the variables here. Now I already went to the variable because I've been doing it so much, I guess. And here is x of t and t1 and t2, which is here x of t, and they should have had a parentheses in t here. And so those are the variables. Press enter. Press alpha, put anything into these entry lines in my programs. Okay, alpha 8.25 plus 2.5 times t cubed. That's in centimeters. And the times are given as 2 and 3. Alpha 2, alpha 3. I always show you what you've entered. You can change it if you want. The higher number for the times has to be in T2 position, which I do automatically. If you put it in wrong, I would switch automatically for this to be in that position. So we say it's okay, and we do the average velocity. Now you notice that here's the formula here, x of t2 minus x of t1. T1 and T2 are the times, you know, and then divided by the quantity T2 minus T1. And we put the variables in here. Here's the T2 is 3 for the time, and T1 is 2 for the time. So it goes in here. The calculator, the program does with quotation marks in here, but you'd put parentheses in, of course, on each side of the 3 and the 2. And divided by the quantity 3 minus 2. And so then we do the calculations of that, divided by 1, and it's equal to 47.5 centimeters per second. And then I change it to meters also by dividing by 100, which is 0.475 meters per second. Never know what the professors are going to ask for you to get. Now so we found the average velocity. Now we're going to find the instantaneous velocity. Of course, you have to differentiate the function here. And when the particle is midway between its positions, okay? So now it's not, you just can't take 2 seconds and 3 seconds and add them together to get 5 and divide by 2 and get 2.5. Even though some guys answered it like that on Yahoo, but that's not correct. They're asking for midway between x2 and x3, okay? Not t2 and t3, okay? Or t1 and t2. So we're going to choose number 2 here for that. And so when we find x at 2, we do these calculations here. Here's the main function. Turns out to be 28.25 centimeters. And then at 3, turns out to be 75.75 centimeters. Okay? And so here's the formula between x2 and x3. x2 plus x3 minus x2. And we come up with 28.25, which we just found, plus 75.75 minus 28.25 divided by 2. And we get 28.25. Mark this all on your paper, and it turns out to be 52 centimeters. That's where the position is in between these times, okay? So we use algebra, of course, 52 in here for, here's the middle, x middle, that's midway point. And we put that into the algebra. It turns out, and solve for t equals 2.596 seconds. And so then we want to find the velocity. And velocity is, of course, equal to the x prime of t. And so we enter the time we just found up here for that into the function. Turns out to be 50.544 centimeters, or 0.50544 meters per second. So we found out that problem. Now, of course, if you wanted to find out other times, sometimes the problem says, we'll find it at 2.5, that, you know. And we can do that automatically by pressing number 2 and choosing number 1 here, which is the in between the times, not the positions. And that turned out to be 2.5 seconds, and we put it into the function, and it turns out to be 46.875 centimeters per second. And we can find other choices too. We can go to 1, and we can put alpha 7, for instance, or whatever they ask for. And it'll put, and here's the answer, 367.5 centimeters per second. If we press 3, quit, we can do another velocity problem if we want, and go back to the main menu here and do another velocity problem if your homework has that, or your test or whatever. So pretty neat, huh? EveryStepPhysics.com. Go to my site, buy my programs, and you might want to subscribe to this site if you want other information from me. I'm going to do a couple more of these problems here in videos, and certainly is worth the price. And, you know, throw away your physics book, throw away your notes, and don't ever throw away the calculator with these physics problems, and you'll be able to do it forever as long as you have the calculator going. And you never know in the future what they might make you take in classes for your job or your career or your family people or partners or whatever, or even kids if you're young and having kids. Who knows in the future? Everybody's going to take physics and calculus, okay? So keep my programs in mind. Hey, have a good one. I'll help you all I can too. You can call me and I'll help you with physics problems, and I know all about this stuff. So hey, have a good one.